We're going to solve now lesson 17, solve problems using systems of equations. This is the key. Page 187, I ready math instruction, 8th grade. So remember, we're going to start with some examples, use substitution to solve the system of equations, study the example. So we have a system of equations, and they're asking me to use substitution to solve the system. So we have the following steps. They use substitution, they find the solution. So I invite you to study that example, and then we're going to answer questions 1 through 7. So for example, here it says, problem number 1, explain why you substitute x plus 4 for y in the first equation of the system in the example. In this case, I'm going to say, for example, you substitute x plus 4 for y to make an equation with just x in it. Just to have x in those ones. And you can see it here. This is y plus 3x equals to negative 4. So if I make the substitution of x plus 4, because it's telling me that y is equals to that value, then I have all x values in that equation, so I can solve for that value of x and then find the value of y. Problem number 2. Once you know the value of one variable of the system of equations, how can you find the value of the second variable? So in this case, you are going to substitute that value into one of the equation and solve for the second variable. The second variable. Okay, that's what we're going to do. Once we find one value, we go back to any of the two equations, whatever you want, and plug in that value and find the value of the other variable. Now here, look at the system of equations at the right. Which variable would you find the value of first? Explain your reasoning and solve for that variable. So I see that x is equals to 2y. So it's inviting me, I'm going to say inviting me to make that substitution in the first equation. So I'm going to find the value of y first. How is it going to happen? Okay, this one is going to be 4y plus x, but x is 2y. Here is telling me that x is equals to 2y, so 2y is equals to 12. 4 plus 2, see, now all the variables are y, is 6y equals to 12. Then we divide by 6, and we have 6 divided by 6 is 1, so y is equals to 2. Now explain that reasoning. So look at the system, and now we're going to explain. So I know that x is equals to 2, okay, x is equals to 2y, so I can substitute y for x in the first equation, and solve for y. And then after following those steps, we have that y is equals to 2, and that will be your solution. That's page 187. Let's move to page 188. Use substitution to solve the system of equations. So I have 2y minus x equals to -9, y equals 2x minus 3. Look at this one. I have y is already solved So it's telling me that y is equals to 2x plus 3. So I'm going to use the first equation. So 2y, but I know that y is 2x minus 3. So open parenthesis 2x minus 3. That means I'm going to find the value of x first. Minus x equals to negative 9. Then apply this to the property. 2 times 2 is 4x. 2 times 3, negative 6. Minus x equals to negative 9. Okay, let's simplify. 4 minus x is equals to 3x. So I have 3x minus 6 is equals to negative 9. Let's get rid of that 6. Plus 6 plus 6. So this 6 goes away. So 3x is equals to negative 3. Negative 9 minus 6 is equals to negative 3. Now in this case, divide by 3. So I have x equals to negative 1. That's the first value that we get. X equals negative 1. Then use the second equation because it's already solved for y. So I have y equals to 2x minus 3. So y is equals to 2 times negative 1. That's the value of x. Minus 3. So y is equals to negative 2 minus 3. See, negative 2 times negative 1 is equals to negative 2. Negative 2 minus 3 is equals to negative 5. It's the addition of two negative numbers. So the solution of the system of equations in this case is negative 1 in x and negative 5 in y. Problem number 5, use the system of equations at the right, this one, 5 to 6, to solve 5 to 6. Graph the system of equations, what order appears to be the solution. So in this case, what we're going to do, the first equation, 2x minus 4. So I'm going to start at negative 4. Okay. The slope is 2. That means you're going up 2 units and to the right 1. So 1 to the right 1 here. And then you're going to graph that line. I don't have a ruler, so I'm going to use this one. I know it's not that fancy, but it'll do the work. Okay. The problem is this line needs to be precise so you can know whether you're going to cross each other. Now the second one, I'm going to use a different color. So I have 2 is the y-intercept. And then you have negative 1 as the slope. Negative 1 means you're going down 1, right 1. So you're going down 1, right 1 here. Down 1, right 1. So here is going to be the solution. So I'm going to use this thing as ruler because I don't have one right now at hand. So it appears in this case, as you can see, that your solution to these systems is at 2, 0. That's an approximation. So I'm going to write here the solution 2, 0. That's what it looks like. Now solve the system of equation algebraically to check your solution in problem number 5. Now as you can see, both equations are solved for y. So I can say that y is equals to y. So if I do substitution, so I end up with 2x minus 4 equals to negative x plus 2. Let me get rid of this x plus x. So this one goes away. So 2 plus 1 is equals to 3x minus 4 equals to 2. Then plus 4 plus 4. So 3x is equals to 6 divided by 3. So x is equals to 6 divided by 3 is 2. Okay, now we need to find the value of y. So I'm going to say that y is equals to x minus 4. You can use that one to that equation. I know that x is 2. So y is equals to 2 times 2 minus 4. So y is equals to 4 minus 4. Y equals to 0. Now I can confirm that my solution is 2, 0. Okay, problem number 7. I have Tom's work to solve a system of equations is shown in this square. Do you agree with Tom's statement about the solution? Explain. Describe the graph of the system of equations. Now I'm going to move here. Okay. So in this case, yes, I'm going to agree with him. So he had y equals negative 2x plus 1, 2x plus 1. Then he made the substitution. So he took this one and put it here. And then he simplified. This is 0. 1 is equals to 3. Their system has no solutions. That's here, this one. That's not true. So in this case, yes, I agree. the statement 1 equals to 3 is not true. Is not true. So there is no solution. The graph of the systems are parallel lines. That do not intersect. Okay, so those lines are never going to intersect each other. They are parallel lines, and that's the solution for page number 187 and 88. And let's move to the next one. Now we're going to have some application problems, and this one is the key. Okay. So the second part is solve real-world problems, applications. So we have the example, Ocean View Hotel charges $100 per day, plus a one-time fee of $40. Beachside Hotel charges $110 per day. After how many days will the cost, it's a cost problem, of the two hotels will be the same. So we're going to start writing an equation. So I have C equals to 100D plus 40. Then I have C is equals to 110D. We use substitution to solve. We're going to have that ended with D equals to 4. So the cost at the hotels will be the same after 4 days. Now, explain what the equation 110D equals to 100D plus 40 represents in the context of the example of the problem. So in this case, it represents when the cost of at the hotels will be equal. Okay, that's the first one. Number 2, suppose Ocean View Hotel charges their fee to $45 and Beachside Hotels changes their daily rate to $115. Write new equations for the total cost of the two resorts. Okay, so we have some changes in the numbers. So in this case, the equations of the Ocean View, so I'm going to Ocean View, or it's going to be C equals to 100D plus 45. That's the fee that changes. And the second hotel, Beachside, is cost equals to 115D. That's the solution for those ones. Number 3, solve the system of equations formed by the equations you wrote in problem number 2. After how many days will the total cost at the two hotels be the same? So we solve those ones. So I have 115D equals to 100D plus 45. So we have, let's subtract, minus 100D minus 100D. So we have that 15D is equals to 45. So then we divide by 15. Okay. So what we have here is D equals to 3. That's going to be the solution. 3 times 15 is 45. So in this case, the total cost will be the same after 3 days. Okay, let's move the page. Now we have an application. It's not solved. We need to figure out the solution. So Roberto got $30 for his birthday. He decided to save that amount and add $5 to his savings each week. Jack, in this case, starts saving the same day as Roberto and put $8 in his savings each week. After how many weeks will the boys have the same amount in their savings? So in this case, let me say let S equals the total savings and W equals to number of weeks. Okay. So in this case, Roberto his savings equals to $5 every week plus the $30 that he put on the bank account. Then we have Jack is equals to savings is equals to $8 every week. So we're going to see when they're going to have the same amount of money. So what I'm going to do is 8W equals to 5W plus 30. Let me get rid of this 5W. So it goes away. So I have negative 5 plus A is equals to 3W equals to 30. And then we divide by 3. So we have that W equals to 10. So the solution, they will have the same amount. In savings after 10 weeks. Okay. Use the situation for problems 5 to 6. Okay. So I have Julia earns $6 an hour babysitting and earns $5 an hour walking dogs. She earned 43 after walking a total of 8 hours at her 2 jobs. Number 5. Complete the system of equations below to represent the situation. Let B the number of hours Julia's babysit and D the number of hours she walks the dogs. So in this case, the first equation will be B plus D, okay, because she babysit and she walked the dogs and she is getting paid, this case, for 8 hours. So these are the time, 8 hours. Then is the money, $43, but she gets paid $6 for babysitting, and she's getting paid $5 to walk the dogs. Those are the two system of equations. Those are the two equations that we have. Then solve the system of equations from problem number 5. Find the number of hours Julia worked at each job. So in this case, I have B plus D equals 8. Then I have 6B plus 5D equals to 43. So in this case, remember that to solve by substitution, we need to find one of the variables. So I'm going to say that B is equals to A minus D. And what I did was move this D to the right side. Then I'm going to apply substitution. So I'm going to have 6. I know that B is equals to A minus D plus 5D equals to 43. Then 6 times A is 48. Minus 6D plus 5D equals to 43. So I'm going to solve for the dogs. Then I have negative 6 plus 5 is negative D equals to 43 minus 48 is equals to negative 5. If we multiply both sides by negative 1, we have that D equals 5. We know the first value. So now here, look at this one. B equals to A minus 5. So B equals to 3. Now the solution is Julia worked 3 hours babysitting and 5 hours walking dogs. Okay, that's the solution. Number 7. What we have, consider the situation at the right. Write a question and a system of equations for the situation. Then answer your questions by solving a system of equations. So you have that Trisha and Joshi are at the start of the trail. Trisha walked 500 feet before Joshi starts. Trisha walks 350 feet per minute and Joshi walks 430 feet per minute. So first we need to figure out the equation. So I'm going to say how long will it take, in this case, how long will it take Joshi to catch up with Trisha? Okay, that's the question. Now, equations. So if we let d equals the distance and t equals the time, then we're going to have that Trisha is d equals to 350t plus 500, and Joshi is d equals to 430t. So if you solve that equation, I don't have a space, so I'm going to ask you to give it a try home. It will take 6.25 minutes for Joshi to catch up with Trisha. Okay, and that's the solution, page 190. I'm going to stop in this one. This is going to be the part A.